Hi everybody, Dr. D again. Now, in this video, we're going to talk about a topic that in summary would be called energy production. Sounds simple, but in fact it involves a number of complicated functions in the body. So obviously if there's a supply and demand problem, which is what energy is all about, if there's a greater demand for energy than there is a supply, you're going to feel the effects. You're going to feel tired, you're going to feel fatigued, you're going to feel lack of concentration, lack of focus. And so ultimately we get back to that question that we've asked in virtually every video, which is, why do I feel like I have no energy? And so you may go to your healthcare professional, express the fact that you feel like you have no energy, and be told, okay, well, how long has this been going on? And you say, well, several months now. So you get the diagnosis of chronic fatigue syndrome. Well, is that a true disorder, or is it the result of some other compromise in some other system that's producing the symptoms of a lack of energy? So in my experience, and in the use of the map in terms of being able to isolate the cause of these symptoms, we're able to identify where in the system the compromises exist that would allow you to not experience sufficient energy to function on a normal basis. Now, energy translates into a number of venues in the body. One of them being the obvious, is you just feel tired and fatigued all the time and don't feel like you have the energy to embrace the day. One of them is also on a biochemical level, involving an organism in all the cells in the body except the red blood cells, called the mitochondria. Now, in any given cell, in any given system, there can be 10, there can be 100, there can be 1,000 of these little organisms, and they have one job. That job is to produce energy. Now, obviously, there are a couple of issues here in terms of this organism being able to perform its job. There are mechanisms involved in the production of energy that are important to be aware of, if not understand. So on a fundamental level, we take nutrients in. Those nutrients are delivered to where they need to go. Everybody's being fed, everybody's fat and happy, and everybody's able to do their job. Now, suppose there's a digestive compromise where you're not breaking down, digesting, absorbing sufficient nutrients to fuel the demand for the energy required. Then the mitochondria is basically sitting there saying, everybody's knocking on my door saying, we need more energy, but in order for me to produce that energy, I need more raw materials. And then the digestive system, either because of a compromise in stress hormones, a compromise in organic function, a compromise in the balance between the good bacteria and the bad bacteria in the small intestine, basically says, oh, I can't supply you with what you're asking me for, so you're going to have to do the best that you can. Now, between the point of digestion and the actual production of energy, there are a series of mechanisms. So these raw materials, in a very basic sense, are taken into the cell, and prior to entering the organism called the mitochondria, they are converted via a biochemical process into another form that is then transferred into the mitochondria. And inside the mitochondria is another mechanism called the electron transport chain, which we're going to discuss in detail in a subsequent video. But for the moment, just understand that it's nutrients into the cell, converted in biochemical process into a form that's fed into the mitochondria, converted in the mitochondria via the electron transport chain into a substance called ATP, which is the storage form of energy in the body. So you can see the potential for compromise at any point along the way here. So if we're dealing with any of the other issues that we've discussed in any of the other videos that require energy, and the demand for energy is far greater than the supply available, then obviously you are susceptible to any number of potential symptoms that in reality are only symptoms, and they are the result of a compromise in the ability of the mitochondria to either access sufficient nutrients or to convert them. Now, one of the most common compromises that occurs, other than the fact that the raw materials are not available or the demand for them is greater than the supply, is the presence of a substance called heavy metals. Now, heavy metals are everywhere. They're in the air, they're in the water, they're in most of the foods in a grocery store that are prepackaged. In most of the supplements over the counter are chelated or bound to a metal so that they can survive the acidity of the GI tract. So when you take them in, you don't destroy the substance that they're bound to. You basically erode the metal that binds the substance, and then that metal is dissolved and it releases whatever it's attached to, and then subsequently you absorb whatever was in the supplement, whatever was in the food. But the heavy metals have a tendency to drift to the lowest point in the biological fluid as opposed to being effectively removed by the body. And as they accumulate, the lowest point in the human biological environment is inside the mitochondria, inside the electron transport chain, which is nothing more than a conveyor belt for the conversion of raw materials into energy. And now you've got these heavy metals lodged in the electron transport chain. The conversion of raw materials into energy is compromised, and no matter what the demand, no matter how many systems cry out for this help and cry out for more energy, the mitochondria simply cannot respond adequately, simply because of the presence of the heavy metals, which is one of the things that we are very clearly capable of evaluating within the context of the matrix assessment profile. I'm Dr. Richard DiCenso. Thank you for watching.